same chapter, we are going to take one more heading of work, energy and power. So when we want to do any work, we want energy. But at the same time, we want to do the same work within the stipulated time, that is 5 minutes or 10 minutes or 2.5 hours or 2 hours, like this only. We are talking about power. For doing work and power, that both energy is important. What do you mean by work here? Work will be explained by force into displacement. This is the way we are talking about. The definition for work is nothing but it's a product of force into displacement. When I talk about a circular path, immediately I can take a circular path. One athlete is running like this only, and he is completing 10 rounds. After completing 10 rounds, he is coming back to the starting point. Now immediately I will ask, what is the work done by the athlete? So immediately we can say the athlete has got 0 work done. What do you mean by that? There is no displacement, he is coming back to the starting point. So whenever there is a circular motion, if you are coming back to the starting point, the displacement will become 0. So work done also 0. This is the way, very important application in our work. So what is the meaning for this one? So we want to do some displacement. That is very important for any work is done. Then only we can accept some work is done when there is a displacement. This is the first fundamental for understanding the work. But we can write work or is equal to F cos theta. We are using a travel bag. The travel bag has got some angle with the horizontal with the earth. Then this theta cos theta, we are doing the work very easily by pulling the travel bag. That is the way we are taking F cos theta also. This coming under power, we are going to talk about what I mean by power. Power is nothing but work done by time taken. The time is very important, the time management is very important for power. We are writing the exam for 3 hours, but at the same time, only 2.5 hours is the writing skill. At the 2.5 hours writing skill is enough. That is our power to finish attempting all the questions. That is also important for us. So power means the time factor will come and dominate. Work done by time taken. Suppose we can write mgh by t also, or sometimes we can write half mv square also by time management. So these are the basic things about, and here we can write force into velocity also. P is equal to, so these are the major applications we are going to see. By seeing this one, we are going to introduce the kinetic energy for objects or moving. It has got possessing only kinetic energy. When some objects are taking rest or simply sitting, that one we can say potential energy, and potential energy in terms of mgh and kinetic energy in terms of half mv square. So these are the basic things we are going to connect with some problem based on gravitational force as well as the conservative force. What is the work done? So by just seeing this one, we will see the main component. Suppose there is a point A and there is a point B. So I can go to the point like this also. This is the path number 1. And I can go by displacement. The shortest distance we can take, it is a path number 2. And I will go by this also, path number 3. So like this only I can take 1, 2, 3. So I can go to the point starting from A to B in 3 ways or 3 paths. Now I am giving what is the work done. Suppose I will say work done for here path 1, and this is W2 and this is W3. Now I am giving the options are like this. W1 is greater than W2 and W2 is greater than W3, and I am giving one more options. W1 is equal to W2, that is equal to W3, and C, W1 is less than W2 and less than W3, and the last is W1 is greater than W2 and less than W3. Now what is the question of this one? This is the gravitational force that has happened on the earth, and here we are going to compare what is the work done in the path number 1, what is the work done in path number 2, and what is the work done in path number 3, and options are given like this only. We are going to compare what is the work done, which will be greater. Suppose the path is very long, means can we say this is great? No. because it was happened on the ground or earth, and the earth is dominated by gravitational force. Gravitational force, and the gravitational force is the best example for conservative force. We call it as a conservative force. So what is the characteristics of conservative force? We have got one is conservative force, one is non-conservative force. Before that we will say conservative force is independent of the path. That is very important. It is independent of the path. So it is not, does not depend upon the path, independent of the path. So when we apply this logic, this presence of mind for this problem, we are getting the option only B is the best answer for this one. Because whatever the path, whatever the way you are reaching the point, whatever the work done will be same, because it has happened on the surface of the earth, and gravitational force is the best example for conservative force, and based on this is independent of the path. We can answer this problem within a second by selecting the option. Here the work done will be same for either path number 1 or path number 2 or path number 3. So this is the very important application connected to work and gravitation. And another one, the force. So what is that force? You can say conservative force. Suppose I will say another one, non-conservative force. It is nothing but example. Frictional force depends upon the path. It is purely depends upon the path. Frictional force, that we call as a non-conservative force. So for this problem, this is the intelligence, this is the presence of mind to apply and get the answer. B is the best answer for this problem. Other A and C and D will be knocked out. So based on that we will do some more problem based on this also. Now we will take this problem. A raindrop of radius or falls. A raindrop, it is nothing but a raindrop, and a radius or, radius is small r, falls. So when there is a heavy rain, we are talking about the raindrop from a certain height h. So they are given some height also, h, above the ground. Now they are asking find the work done by the gravitational force by the raindrop is proportional to. They are giving some options, proportional to r and r square, and they are given as r cube, and the last one r power 4. Here we are coming to the conclusion. They are given raindrop. So immediately we have to get the presence of mind is very important. What is the shape of the raindrop? It is nothing but sphere, and a sphere, what is the volume to be taken is 4 by 3 pi r cube. So the pi r cube from the formula of mathematics is got the very good presence of mind selecting C is equal to r cube. That is the work done by that one. Our work done is nothing but how can we take in this problem? So this is the volume to be taken, or work done is nothing but mgh. But here we are going to discuss about how will it take mass. So we have got one formula, density. This is very important. Wherever you go, this application come mass by volume, or mass is nothing but density rho into 4 by 3 pi r cube. So when you substitute here W is equal to, that is the work done, rho into 4 by 3 pi r cube into G into H. So when you are analyzing this formula, The work done is a constant one, 4 by 3 constant, pi is constant, g also constant, h also constant. Only the variable factor is r cube, or w is directly proportional to r cube. So depends upon the radius, depends upon the volume, the work done will be there according to the raindrops. The raindrop, basically we have to give the presence of mind, it is nothing but sphere. So when you talk about sphere, immediately think about the volume of the sphere and the radius is coming and dominating. By saying that, you can select the option C is the best answer for this problem. So this is the way the problems will come under work, as well as we are going to do some problem based on energy also. So based on this one, we are going to see what is the effect of the energy as well as the power in our some problems, how the formula is affecting. At the same time, we are going to take one problem based on this one. A crane lifts a mass. So what is the meaning for crane? What is the difference between escalator, lift and crane? We are going to discuss one by one. A crane lifts a mass of 100 kg to a height of 10 meter in 20 seconds. Now the question, find the power of the crane. Find the power of the crane. So they are given some options like this only. The SI unit of power is watts, 100 watts, B 200, and C option 250, and last option D 500 watts. Here we want to calculate power. They are given the mass as well as the height and time also given, and find. From the given data, we are able to find out what is the work done. Our power is equal to work done by time taken. Here work done is nothing but mgh by t. But we can apply the formula. G you can take as 10. They are given here. G value you can take. So there is a difference between G value. When they are given 10, we have to take. If they are not given, we have to take only 9.8. That is very important. Then substitute the formula. 100 into 10 into height is 10 meter divided by time 20 seconds. So when you are simplifying this application of this formula, this work done is nothing but mgh here. That is very important. That work done is nothing but mgh, and here when you solve it, you will get the answer 500. So the answer is D. This is the power of the crane. What I mean by crane means the crane is lifting from the big boxes, containers, from ship to train or ship to lorry. The big boxes, the crane has got the potential or the power, depends upon the boxes to be carried. So this is the problem based on, but they are not committed anything about what is the work done by. It may be the height is given, immediately we can apply potential energy. That potential energy we have got mgh and time. So this is the way the problem will come. By taking the paper and pencil we can do, or without taking the paper and pencil we can simply calculate m into g into h by t and get the answer within 1 minute, or even less than 1 minute also we can get the answer. So this is the way we are doing some problem based on power. Then we are going to do some problem based on velocity also. Now we are going to take what is the energy equivalent of 1 kg mass. Now there is a problem based on these are just one sentence they are given. What is the energy? What is the energy equivalent to of 1 kg mass? So that is the way they are given some options for you. 9 into 10 power 13 joules, and option B also they are given 9 into 10 power 14, and C also 9 into 10 power 15, and lastly D also 9 into 10 power 16. So they are given some options like this only, but here for doing this one they are given only one sentence. What is the energy equivalent to 1 kg mass? Here the nuclear reactor we are having that one producing mass or electricity by, there is a loss of mass by taking, this is the Einstein formula, E is equal to mc square. For doing this problem, because there is a mass and there is a energy, so there is a connection between these two by taking this Einstein's 21st century formula mc square. Now you substitute here E is equal to the equivalence 1 kg, 1, c is the speed of light, and that is nothing but 1 into 9 into 10 power 16 joules of energy. So if we know this formula immediately by understanding the problem, they are given energy, they are asking the energy, they are given the mass. There is a relationship between energy and mass by taking, this is the fundamental formula. By using this formula, we are able to get the option 9 into 10 power 16 is the best answer for this problem. So like this only there is a problem will come, but this is most of the applications coming in a nuclear reactor. Nuclear reactor is working under the principle of nuclear fission. We are breaking the heavy element of uranium U-235 and 92. So that breaking the heavy element into small fragments, that fragments we call as a nuclear fission only. But nuclear fusion is not possible on the surface of the earth. Only at very high temperature, hydrogen and helium fuse together, one in star, like nearest star is sun. So based on that, this is the problem will come under energy also. And based before that, we can connect one more problem on that one, energy. Here I am giving the same problem. I am giving 1 microgram of uranium. How much energy will be released? Sometimes the same problem, the same previous problem, the same application is coming, but only thing I already told, the problems to be done only in SI unit. SI unit is very important. 1 microgram to be converted 10 power minus 6 into 9 into 10 power 16. That is the energy, or you can say final energy is nothing but 9 into 10 power 10 joules of energy. So here this microgram to be converted into SI unit. So you are applying the formula correctly, but if you fail to convert it to SI unit, the options may go wrong. Just like that we can compare this problem in the previous case, but only thing they are given like this indirectly, U-235 or 92, it is the raw material for our nuclear reactor. At a nuclear fission, it is working under the principle of nuclear fission only. So the uranium is the very important, and there is a loss of mass, energy will be released. That is the Einstein, that is the way he is producing lot of energy, and this energy we are producing electrical energy for our usage. So these are the basic things, And we will do one more problem based on elevator. What is the difference between elevator and escalator? There is a one word, elevator and escalator. Escalator will take infinite number of people, but elevator will take 10 people, 12 people or 15 people, as a finite one. That is the difference. Based on that we will do one problem. An elevator can carry a maximum load. So this is the elevator, and the maximum load they will take here, it is nothing but 1800 kg. So this is the maximum capacity of the lift. If anybody is coming one more, definitely it is more than 1800, they will ask to go for second chance. So this is the elevator plus passengers is moving up with a constant speed. That is very important. Is moving with a constant speed. That is 2 meters per second. And when the elevator is moving, it is also facing some frictional force. That frictional force is very important. Here, the frictional force is, they are given here as 4000 Newton. Now they are asking, the elevator has got some motor. What is the minimum power delivered by the motor to the elevator? What is the minimum power? So they are asking the minimum power. So they are asking minimum power, and they are given some options also like this. So they are given the options in other than SI unit, that is nothing but kilowatts. 44 kilowatts. And here one more, C, 88 kilowatts. And last one, 8 kilowatts. So I have given some options for you. You have to calculate the power. So minimum power means, so what is the way we are going to take? It is going 800. First the lift is going up, means it has to come across the gravitational pull or gravitational force of the earth, and it is going. And second, it is going with the speed, and it has got some. And then third one, so there are 3 types of actions of that we are going to calculate one by one. So before doing this problem, we should not jump to the conclusion it has got only one force or opposing force, but at the same time the power depends upon the gravitational force as well as the frictional force as well as the constant speed of the kinetic energy. We will do this problem by taking this data. So there is a downward force. The first case, there is a downward force. There is a downward force, that is F equal to mg plus F. That is nothing but to be taken as 1800 into G value you can take as 10 plus what is the frictional force, 4000. So if you calculate, it will come 22,000 Newton. So we are able to calculate the force on that one, and the next one we are going to calculate what is the power. So what is the formula for power? We have already studied. It is nothing but work done by time taken. But the given data is not satisfied the work done by time taken. So we have got one more formula, that is then made force into velocity. So velocity data is available and force is available. We can substitute here 22,000 into velocity is 2, or it comes to 44,000. But all the options are given kilowatts divided by 1000, or we are getting 44 is the best answer for this problem. For doing this problem, what is our important application? Then we have to find out when the lift is going up, it is always pulled down by the gravitational force. That gravitational force depends upon the downward force, depends upon the mg, total weight of the, then there is a frictional force, the 4000. These two forces are adding, that is the final force to balance. Then when the lift will go up, then the power given by the motor, minimum power, depends upon the force, and depends upon the speed. It is a product of force into velocity. We are substituting 44 kilowatts is the best answer for this problem. We will do one more problem based on that. There is a problem of presence of mind. Object is falling freely under the action of gravity. Falling freely, that is very very important. Falling freely under the action of gravity alone in vacuum. In vacuum, that is also another condition. In vacuum, which of the following quantities remain constant during the fall? That is the question here. Which of the following quantities remain constant during the fall? They are given the options. First one, kinetic energy, and second one, potential energy, and C, they are given total mechanical energy, and D, total linear momentum. Total linear momentum. So once again I will repeat the question for you. A body is falling freely under the action of gravity alone in vacuum. That is very important. Which of the following quantities remain constant during the fall? So this is the way we are going to see either kinetic energy or potential energy. We can say it is a total mechanical energy is the best answer for this question. Why we are taking total mechanical energy? The total mechanical energy remains constant during the fall because under action of gravity alone in vacuum. If it is coming under atmosphere or if it is coming under atmospheric, the air friction will be there. The air molecules will make some hurdles for the falling down. That is the way they are putting the condition. The answer is only the total mechanical energy is constant throughout the fall. So based on that, this is the main problems to be solved by taking this heading work, energy, power. For doing the work, energy also important, either kinetic energy or potential energy. For doing the work within the time or within the time management, the energy also important here. So based on that, still we will do some more problem, but at the same time, we are able to think about how the problems are coming within the short span of time of we are get the answer within 1 minute. That is the way we are taking some problem as an example. And next one, okay, thank you.